Shooting up the walls of heartache, bang, bang. I am the warrior. I am the war. Oh, hello. Oh, I didn't realize I was recording. Yes, hello, we're back with another exciting episode of How to Do Stuff with Mr. Stevenson. Today, we're embarking on the exciting journey of area of polygons and composite figures. So, without further ado, I have a few sample problems for us to do together. We'll start off with area of polygons. Here is a classic looking hexagon. Hexagon, of course, is a 6-sided polygon. This one's already kind of broken up for us and has all the measurements. In this picture of the hexagon, it's given basic sides. Basically what we're looking at here is all the sides of this hexagon are length of 6. We could also say that it's broken up into 1, 2, 3, 4 shapes if we want. But I don't want to do 4 shapes. At this point, we're going to break this hexagon up into 3 shapes. I have 2 triangles on the ends, and those are identical. And then I have the basic rectangle right here in the middle. Let's use these formulas to solve this problem. Let's start with the triangles, and I only need to find the area of one of them because these two are identical. So if I were to multiply the base of the triangles times the height I have here, if you look at this side, it shows that this length right here is 10 inches. You can see that here. So this is 10 inches, just like this is 10 inches, just like this is 10 inches. So I have a 10-inch side, and the height is already shown for us because we talked about this, how the base and the height have to form this right angle right here. I'm going to highlight this. That's our right angle. We need that. Okay. That tells us that that this is a base and a height. So I take 10 times 3, which of course is, yes, 30. So let's put that here. We have a base times height of 30, and then we have to divide by 2 because of the area formula for a triangle, and 30 divided by 2 is 15. So the area of each of these is 15. Okay. So now I got to find the area of the rectangle in the middle. That's going to be pretty easy because we know that rectangles are just base times height or length times width, but in this case we're going to use base of 6 and a height of 10. And if we take 6 times 10, we get 60. And so the area of this is 60. So if I were just to add those all up, I would do 15 plus 15 plus 60. And 15 plus 15 is 30. And 30 plus 60 equals 90. Area equals 90. This is in inches. And of course, square it. Don't forget that. There's your answer for that one. So that's how to find the area of just polygons that have different shapes rather than just area of triangles. Oh, I was going to do this too. Let's throw a couple of shapes in here. So we have area of triangles, area of rectangles, and area of triangles. There we go. Get that in there, and then an area of a rectangle, just a little rectangle right there. That way we have our formulas all neatly organized. Area of a rectangle, area of a triangle, like so. And that's the formulas I'm going to use to solve everything. And when you get shapes that are different, that have different number of sides, and you can break them up into triangles and rectangles, all the better. And that makes it quite easy, I think. And I think you would agree with me, because that's what I trained you to do, is agree with me, right? Yes? Okay. And I keep my formulas here. So, next problem, we'll continue to find the area of a composite figure using this picture right here. Just your typical arrow pointing to the right with certain measurements already built into it. So on a composite figure like this, basically means it's another figure, another polygon built out of other shapes. Yeah, this one has 7 sides. That's called a heptagon. And so everything is kind of already set for us. All we have to do is kind of break it, and that'll be pretty simple here. I'm going to ungroup these. And if we take this little line and we pop it right here, we've broken it into a triangle and a rectangle. So I have my formulas all ready to go over here. That should make this one pretty easy, and we should be done with it in no time. So let's start with the, let's start with the triangle. It's maybe a little bit harder, but that shouldn't be a big deal. Now right here, if you look at the sides of the arrowhead, you got a 2-yard side and another 2-yard side. So that's so far is 4 yards, but I got this missing right here, but not really missing, right? Since a rectangle, by definition, a rectangle, the opposite sides have to be the same length. That means this is 6, and that means this side right here is also 6, right? So I actually have the full length of the rectangle the way I wanted. So I'm going to point here, I have 2, 4, plus 6. So this length right here is 10. So in my triangle base, here's my base, I have 10. And what's the height? So that's going to be a little bit trickier here. If I'm going to look for the height, I'm going to take another line tool here. The height of the triangle would go from, of course, the highest point down at a right angle. So this is the right angle right here, exactly what we want. This is the base of 10, this is the height. So what is the height? Well, you can figure that out based on the other measurements we have. If you look down here, the length of the whole arrow from tip back to the 6-yard side is 18 yards. And I'm given that this side of the rectangle is 12. So that means if I were to extend this out, to the black line here, and so it's 12 yards from here, and then from here to here, how do I get to 18? 12 plus what equals 18? 12 plus 6. So this side is 6 also. So the base is 10, because we have 2 plus 6 is 8, plus 2 is 10. And the height here, as we just found, was 6, because 12 plus 6 equals 18. So I have 10 times 6 equals 60. So the area of the triangle equals 30 square yards. And then of course we have the rectangle, which is the easiest of all, and that is pretty simple too. If we take the base of 12, if we take the base right here, or the base here is 12 times the height of 6, you get 12 times 6 equals 72 yards squared. And there's your two answers. Put that in here. We'll put area equals 72 yards squared. So there's my two answers. And then when I add them up, because I have 72 for the rectangle and I have 72 for the triangle, and if I take 72 plus 30, I get 102 yards squared. So that's my total area. And that is how you find area of composite figures like this one. And as always, if you have any questions, you know exactly where to find me. Or maybe you don't know exactly where to find me, but you somewhat know where to find me. Some of you know where to find me. And maybe I'll see you then. Till next time.